Hey guys, today I'm going to be presenting my topic on the Rubik's Cube. Many of you have probably already seen or played with one of these, and there are probably some of you who can even solve one. The cube has 6 different colored faces, and every single piece of the cube can intertwine and mix with one another. But the intricacies that go into this toy are really something interesting to look into. To give some background on the cube, it was created by Rubik in 1974, and it took him about a month to solve his own puzzle, all while outsourcing to experts in puzzles and various researchers to help him. Times are different now, as I'm going to talk about the various methods people use for solving this thing in a matter of seconds. First, we need to see how many different possible permutations there are for this puzzle. The equation to find this number can actually be done with knowledge we've learned in this class, so let's do it together. The cube has 8 different corners and 12 different edges, and so to arrange 8 corners would give us 8 factorial different possible permutations. Each corner has 3 orientations, but only 7 of those corners can be oriented independently, as the last one is dependent on the previous ones. This gives us 3 to the 7 different ways to orient the corners. For the edges, we have 12, but they have to be in what we call an even permutation when the corners are. This gives us 12 factorial over 2 different permutations for the edges. As it was with the corners, only 11 of the edges can be flipped either side, which finally gives us 2 to the 11 for the orientation of the edges. Put this all together and you will get about 43.2 quintillion possible permutations on the cube. Now, if we count the possible permutations through disassembling the cube, this would take away the limitations of the last corner and the last edge being dependent on the others. Changing the equation to fit these adaptations would give you 519 quintillion different possible permutations. Although these figures might seem intimidating, I'll explain to you how we can easily solve this thing in a matter of seconds. The various methods used to solve the cube all involve a process of using a proper algorithm for a specific pattern you're faced with. To throw an analogy in the mix, solving a cube is like building a house. You start from the ground up. One way we learn various algorithms is using a notation for the moves on the cube. Every single move you can do on the cube is represented with a letter, such as R for turning the right side clockwise, F for the front, and so forth for the different moves. If you were to turn the right side counterclockwise, we would say R prime, and the same principle goes for every other move. This notation is what allows you to learn any algorithm on the cube, as they are all written using this notation. The most popular but inefficient method to solve is the beginner's method, in which you build it from the white face and solve it almost piece by piece throughout the layers with a series of fairly simple algorithms. This method is quite inefficient compared to its adversary methods that allow people to do less algorithms in less turns, resulting in a more efficient solve. One of the most popular speed solving methods, as we like to call it, is CFOP, or the Friedrich method. CFOP is an abbreviation for cross, first 2 layers, orientation of the last layer, and permutation of the last layer, which is the order in which the cube is solved using this method. First, you solve the white cross, then the first 2 layers using a pair system, then you solve the yellow face by orienting the last layer, and finally you solve the last layer with a couple permutation algorithms. Many other speed solving methods exist that some people prefer over others, like Roux, ZZ, and variants where people incorporate techniques from multiple methods of solving. This begs the question, which way of solving is the most efficient? If we look at these graphs here, we can see a comparison with the different methods I've listed. As you can see, the beginner's method is very inefficient, as it takes on average almost twice as many moves as its 3 other counterparts. When we look at Roux, ZZ, and CFOP, we can see they aren't very different in terms of efficiency, but Roux takes the edge with slightly more efficient results than the other 2. The world record for the fastest cube solve in competition is 3.47 seconds by this guy, who I won't even try pronouncing his name. But he used the CFOP method for this solve, solving his cube with only 31 turns and at almost 9 turns per second. But these methods aren't exactly the most efficient ways of solving it, since robots and AI came in the picture. With the innovation of informaticians and engineers, they've created the Sub-1 robot. The robot is given a scrambled cube and with scanning technology is able to find the most optimal solution to solve it, usually in 20 moves. The robot uses a unique method of solving called the Herbert-Kosiemba's 2-phase algorithm, which is humanly impossible to perform but is accessible online. You can give the optimal cube solver any scramble and it will find the most optimal solution in 20 moves or less. In 2016, Sub1 was able to break a world record and solve the cube in only 0.637 seconds, using only 20 moves. This brings me to the story of what cubers call God's number, which is the lowest number of moves to solve all 42 quintillion possible permutations of the cube, and that number is 20. This took mathematicians about 30 years to figure out, slowly decreasing the upper bound for the maximum amount of moves it takes to solve any possible cube permutation, and years went by until it reached the lower bound of 20 moves. To relate this to the class, as we've talked about the P versus NP problem, if we could be able to prove that P equals NP, its consequences could hypothetically mean we could find God's number for any size cube, because right now, we're not even close to finding it for a 4x4 cube or any cube that's larger. This is because any n by n by n Rubik's Cube has been proven to be NP complete by some computer scientists at MIT in 2018. Other interesting things about the cube is how it lends itself to the application of mathematical group theory. Now, I am by no means educated on group theory, and I'm sure Derek knows a lot more about this than I do. But simply put, it has helped the speed solvers find different algorithms to solve the cube more efficiently. They are mainly found by algorithms using a commutator structure of the form x, y, x prime, y prime, where x and y are their own specific moves on the cube, such as a regular r turn, and the latter half are their own inverses, just like r prime. They are also found by algorithms using a conjugate structure of the form x, y, x prime, which we call a setup move that applies to almost every stage of solving the cube. Other cool things to bring up about the cube are its variant puzzles, all based on the original 3x3 puzzle, such as the Scube, Pyraminx, Megaminx, and other puzzles that each have their own intricacies as to solving it. There's even a cube called the GAN Eye, which connects to your phone, allowing you to see a digital representation of your cube as you solve it, giving you the ability to time your solves without having to press a timer each time, along with various other cool things on the app. I want to thank you for watching this video this far, and I hope it doesn't make the test any harder.
No! We need ideas how to stop the terrorists! An 18-wheeler spins out of control, and it's all like, brush! In this huge tanker full of dynamite, craw, craw! Those aren't ideas, those are special effects! I don't understand the difference.